Okay, you should be able to see the presentation now.
Yes, we can.
Okay, great. Just let me see how to start on the slideshow here. Okay, I guess you're seeing my screen now, right?
Yeah.
Yep.
Okay, okay, then let's start. So thanks everyone for joining. The topic we have today to present is something that we've encountered during the deployment of Geode on Kubernetes and as part of a service mesh. So what we found is that we have servers with stuck threads indefinitely waiting for replies from remote servers. So as mentioned, we have Geo deployed in Kubernetes and as part of a service mesh. Now, the service mesh used here is Istio. Istio is an open source product. It's a realization of a service mesh which uses the Envoy proxy. So Envoy proxy is another open source component. It's basically a proxy sidecar container for Kubernetes that's been utilized as part of Istio to provide a complete realization of a service mesh. Now, the interesting stuff here is that if you have an Envoy sidecar container deployed as part of your pod, that Envoy sidecar will be intercepting all TCP traffic using IP table rules. So all TCP traffic will be intercepted and proxied by this Envoy container, but the UDP traffic is left untouched. So it won't be intercepted, but it shouldn't also have any problems in communication. UDP won't be aware that there is any kind of proxy there. Only TCP traffic will be intercepted and features applied on it as configured. Now that's some background on the situation. What would a deployment look like? Now this is the most simplified case that I can show, but this should be completely enough to understand the problem that's happening. So we have two Geode servers, each one deployed in its own Kubernetes pod. And each of these pods has a proxy sidecar injected. So this would be an Envoy proxy injected here by the Istio service mesh. This would be a deployment with the conserve sockets parameter set to true. Now, the connections between the two Geode servers, what would they look like? So we would have something like this. So the server 1 establishing a connection towards the remote server 2. All of this would be one logical TCP connection, but actually these are three independent TCP connections. So the first TCP connection would be between the server 1 and its local proxy container, the second TCP connection between the two proxy containers, and the third one, of course, between this proxy 2 and the server 2. Now, in this one logical TCP connection, we have 3 actual TCP connections involved and 6 different sockets. So 1 on the server, 2 on the proxy container, again 2 sockets on the remote proxy, and the socket on the remote server. So this would be one TCP connection where the server 1 would be sending data towards the remote server. And since Geode works in a way that it uses these TCP connections as one-way connections, then the reply would be returned over a different TCP connection, which would be pretty much the same, just sending data in the different direction. But the same logic applies. So one logical TCP connection, but consisting of three actual TCP connections. Mm, okay, so this would be the main setup. Now, uh, here and on top, this is pretty much uh, the same picture, just laid out a bit differently, so we can below have a sequence diagram and see what's happening with the packets being exchanged. So to start with, we need to establish the connections. So we will have a three-way TCP handshake on each of these TCP connections. Again, this is quite simplified because the problem isn't really related to the connection establishment. I'm just trying to set up the base situation to describe the problematic. So three TCP connections established for server one to send the data, and a different logical but three TCP connections to receive answers on server one from server two. Okay, so server one, when it tries to send some data to this remote server, uh, first we get, of course, the TCP push packet sent from server one. Now, server one is completely unaware of this proxy. Server one is trying to reach the remote server two, but this traffic is intercepted by this proxy. The proxy container receives the TCP packet and sends back a TCP acknowledgement. So from server one perspective, this data packet has been successfully received by server two. But in reality, this packet is only on the first proxy container. And this proxy container then will send the data forward to the remote side. So the next uh, data is sent, the same data packet is proxied from this container towards the remote proxy. The remote proxy sends back, again, an acknowledgement and sends the same data packet to the remote server, which then, of course, acknowledges it. So we've seen the data packet travel through three different TCP connections before it arrives on the remote server. Now the remote server, based on this received data, will send a reply to server one, which will work in pretty much the same way. So the second server will send some data, which is acknowledged by this proxy number two. It then takes this same reply and sends it towards the remote server or the remote proxy, so proxy one. And this container then sends the reply to the final destination, to the server one. And this would be a working case, so where everything goes fine in the connection. Now, let's get into the problematic situation. So again, a starting point, three-way handshake on each of these TCP connections. We have connections in both directions. Now the server one again tries to send some data towards the remote server two. Data is sent and intercepted by the local proxy, which acknowledges the data package and proxies it towards the remote proxy. Now, if we at this point restart this proxy 2, what can happen? It won't happen every time, but often enough. This data packet can be inside of the receiving buffer of the socket on this proxy 2. And once the proxy 2 is being restarted, it will close all of its sockets. And again, if the data package is still in the receiving buffer of this socket while the socket is being closed, a TCP reset will be sent back. So this data package hasn't been read by proxy 2. It hasn't been read, it hasn't been acknowledged, but the socket was closed while the data packet was still in the receiving buffer. Uh, Basically, the data packet is lost, and a TCP reset is sent back towards proxy 1 for this data packet. Um, what happens from here on? So this proxy 2 is restarted. It will be closing all of its sockets and terminating all of the connections. So the connection between proxy 2 and the remote server 2 will be closed with FIN and acknowledgement to this FIN and the FIN being sent right back. So we have this middle connection between the proxies terminated, and we have this remote TCP connection terminated. The TCP connection between the first server and the proxy 1 will also be terminated because the proxy 1 saw that this socket doesn't have a connection anymore. And since Envoy has an internal mapping of these two sockets, so it knows that data on this socket here on the left is always proxied forward through this socket on the right, and the right socket is closed, so the left socket has no purpose anymore. So this connection is also closed. So the whole logical connection and all three TCP connections are closed. And in this situation, we have server 1 who thinks that it successfully sent a data package to server 2 because it received a TCP acknowledgement at this point. But the data package was actually lost due to the container restart here with the proxy 2. And server 1 is at this point waiting for a reply from server 2. But server 2 has absolutely no motivation to send any reply because it never received a data package for which it needs to send a reply. And additionally, all other TCP connections in which this proxy container is involved will also be closed, including the connection over which a reply would be potentially sent from server 2. And what we end up in is, again, server 1 indefinitely waiting for a reply on a data package that was never received by server 2. Um, what uh, what can Geode do in this case? Geode has two options. So this Geode server has two options. One option would be to indefinitely wait for a reply, and a second option would be mm, to terminate or to stop waiting for a reply when this remote member leaves the distributed system. Now, why will server 2 not leave the distributed system? So to start with, this remote proxy doesn't intercept UDP traffic, so the health checks will be working fine between the two servers. So although TCP connections are terminated and TCP traffic is for a short period of time not possible, UDP traffic is still happening successfully. But even if the UDP traffic was blocked as well, it wouldn't help a lot, and the remote and the server 2 wouldn't be evicted because the restart of the proxy is done in a matter of seconds. So 1 to maybe 3 seconds will be lost while the proxy is down. It comes right back up, and 3 seconds wouldn't be enough for server 2 to get evicted. So the first server is only left with waiting indefinitely for a reply from the remote server. Uh, this would be the first of two problematic scenarios. The second problematic scenario is pretty similar. So again, connections successfully established between the two servers and between the proxies. The first server sending a data packet, which is again acknowledged by the first proxy, sent forward to the remote proxy, again acknowledged, and the remote proxy, in this case, successfully sends the data to server 2. server 2 acknowledges it, then we finally have a successful exchange of data here. Now server 2 is sending the reply, and the reply gets to the proxy 2. It's acknowledged. The reply is forwarded to proxy 1, but if we do a restart of the proxy 1, and if a similar scenario happens as in the previous one, so if this data packet is left in the receiving buffer of this socket while the socket is being closed, then again, we have our TCP reset sent back. We have this data packet lost. We have the reply from server 2 lost. And yeah, the rest of the connections are closed as in the previous example. So connections working in both directions, they are closed. And again, server 1 is waiting for a reply that will never come because it was lost here between these two proxies. And that will be pretty much it. So server 1 is waiting indefinitely. Now, what's observed on the servers? The first thing you will see is in the server logs. So you will see stuck threads being reported, the partition region message processor. So this is the first thing that makes you see that there's something fishy going on. What's less obvious is another thread that's stuck and that's not reported in the server logs. You can just see this by examining the thread dump. And it's the server connection thread that's also stuck at the same place, and it just doesn't do anything. It waits for a reply from the remote server. And this is all with the conserve sockets set to true. We did some investigation also with the conserve sockets set to false. And in this case, you will not see the server logs reporting any stuck threads. But again, if you examine the thread dump, you will again see this server connection thread stuck at a certain place, and again waiting indefinitely. And yeah, that's actually it. So some lost data packages between the two servers will be causing some stuck threads in the servers, which are waiting for reply.
I had one. Sorry, go ahead.
Yeah.
I just had one sort of general question. Is this behavior? Were you wanting to have Istio intercept and proxy these peer-to-peer connections? Like, was that intentional, or is that just a side effect of trying to use Istio for letting clients discover servers or WAN or whatever? Like, is this? Were you wanting to actually use Istio between the peers and add policies or whatever else you'd want to be doing with that? Or is this just something it's doing?
No, this part is actually intentional. So the idea is for Istio and then to intercept all traffic, and for us to apply some of the Istio features on that traffic. For example, not having to set up the Geode MTLS between the members, but leaving that job to the Envoy containers. The thing is, if you have a bunch of microservices which are implemented using different technologies, most different open source technologies, and if you want to enable security and MTLS on all of them, you will face a bunch of different configurations to enable and disable that MTLS. But if you use Envoy, then it's unique. It's one parameter for the whole set of microservices.
Okay. Yeah, that makes sense. Yeah. Okay. So because one workaround I was going to suggest is you could actually, I think you can force all the traffic to go through UDP. We have some setting to say send everything through UDP, but that wouldn't help in this case then, or that wouldn't do what you want. So.
Yeah. I don't know if there are any other questions. I mean, since there are not, I guess that the problem is quite clear now. What our question would be, is this considered as something that should be improved in Geode? I mean, this is maybe a kind of unusual setup with the proxies in between the servers, but still you can have a lost data package between the servers, trigger your servers to get stuck.
Yeah, I mean, it does seem like it'd be nice if Geode was more resilient to losing one of these connections. So coming into this when I was reading about that, I was thinking about all sorts of solutions that would actually end up using more UDP, right? So, either go over J groups, or maybe we start using there's like Aeron has a reliable UDP messaging, or Quick or something, because basically you're asking for another reliability layer on top of TCP, right? Like TCP already is trying to do reliable delivery. And then we're saying, well, we can't trust that, so we need another layer on top. But that means maybe we should switch to a technology that's doing, implementing the reliable transmission at a higher level. And most the stuff I know about actually uses UDP anyway. So, so I guess if we're looking about a TCP-based solution, I mean, it does still seem like it's something that'd be nice to have. It will require changing the protocol for sure, right? Because you have to be sending like message sequence numbers and acknowledging those sequence numbers and stuff like that. If anybody else has opinions on it.
Can I ask a question? Is there a way to configure Istio for an end-to-end ACK here? I can imagine that it would cause, larger buffer sizes on the intermediate nodes, on the proxy nodes. Is there anything like that? It seems weird to me that this message is being ACKed before it's reached its destination.
Not so, as far as we know, there's nothing that could configure Istio, that could configure Envoy to behave atomically on these three TCP connections. They're just separate connections.
And other scenarios, I've seen people, that if they don't want to have each application configure security differently, like they'll use something like IPsec or something, right? So they're actually setting up, like, securing up basically all the connections between two machines. But I don't know if that's really something that you can do in Kubernetes, or yeah, probably not.
Yeah, I wouldn't know really, but it's not just about security. There's a whole list of features provided by Istio that are very convenient to manage, to monitor, to troubleshoot the set of microservices, the whole mesh.
I wonder, you, Dan, suggested that we probably would have to put in place a higher level protocol. Are there any smaller tactical changes that might move us in the right direction?
Well, we tried to investigate we tried to see whether there are any convenient options or convenient changes in Geode with smaller impact that could help here, but we weren't able to find anything. Maybe something, maybe a an option that could prove, potentially that could prove as less work is the setup with conserved sockets set to false. But that's currently just an idea, because with that setup we see that no stuck threads are reported in the geode logs, but still we see in the thread stack something. So the situation is a bit better, but still there's work to be done if we want this additional layer of reliability. So in short, nothing convenient and nothing with a small impact in Geode that we have discovered so far. We would definitely need to improve the application logic.
Yeah, and conserve sockets false, I don't think will help you, because yeah, you're still going to end up with stuck threads. And I think like you kind of outlined, like we don't have, by the time we're asking for a reply, we may have already lost the message, right? We need something that's actually buffering up what message we would need to retry if we did create a new connection, right? So by the time we're actually waiting, we've forgotten about what message was sent. And then some messages don't have a reply, or they bounce around the system, right? So they go in a circle, and so there's all these complicated patterns that happen. So it it really needs to be down at the individual connection level, that we're buffering up the data that was sent and then retrying it, figuring out a way to make sure that it gets to where it needs to go. I mean, another crazy thought, I don't know if there's anything out there that does this. There might be something, other proxy that you could put in put outside of the Istio level that intercepts the traffic and then make sure that it gets reconnected and retransmitted. But I don't know, off the top of my head, I don't know if there's a product that would actually do that.
Yeah, so any solution would definitely take a while to design, to implement. But basically, our question for today is, would an improvement, if it was if the lead was taken on Ericsson's side, and if we would to investigate this further and possibly find an improvement, a solution for this, would something like this be accepted in the community? Because it seems like quite a change.
The goal seems to be a really good one. I think it would depend on the solution we pick.
I will say, like, we've talked about refactoring some of that connection code for all sorts of different reasons. So I guess, yeah, I would kind of agree with Alexander. Like, I think it depends on what we're suggesting we're going to do. I think in general, yeah, saying can we be more resilient to having these connections fail seems like a good thing. So some of the other things, just for a little more context, I know that the TCP connection code that we're talking about here is pretty old at this point. We've talked about, so some of the other refactors we talked about doing, we've talked about replacing it with NetE. We've talked about, making it more pluggable, so you could plug in something like Aeron or whatever. So we've talked about all these other refactors involved with it. I don't want to necessarily conflate that with this change, but that is something we could consider as part of that. I think whatever we do, we'd have to consider rolling upgrades, right? So we basically we'd have to be able to handle a mix of servers that have new code that support some new protocol, and also servers that are still sending data the old way. So that's something we'll definitely have to deal with.
So it seems, I think Alberto was going to say something.
Yeah, well, listening to you guys, it sounds to me like this would be a change in a major release. This is most probably will not fit in a minor release, because there will be a change in the protocol, which is risky and big. And also, if we have to support the rolling upgrade, it will be probably quite hard. So, yeah, it sounds like, I mean, there isn't any easy solution for this.
Okay, but yeah, your answer is it's pretty fair, I'd say. If we are interested in this, I guess we should investigate what a solution for our problem would be, and yeah, present it and see how impactful it is, and if it might be acceptable.
Why doesn't something as simple as timeouts save us here? Why won't that work?
I checked the code, and for these messages, I mean, I'm not an expert, but timeouts are not being used. And I think timeouts could help in the first case, but not in the second case, because in the two cases that were described, well, I don't have it right now in my head, but you have to know if you have to resend messages. Sometimes you don't have to resend a message because it was received by the other side. I mean, depending on the case, the message reached server B or server 2, I don't know how you called it. And you don't know. I mean, the guy who sent the message, who is waiting for the response, is not aware if the message was received or not. So, well, I guess we would have to at least add some IDs to the messages to make sure that it's not a resent message. Maybe we already have that in Geode. I don't know.
Yeah, I don't think at the peer-to-peer level. So like for peer-to-peer messaging, the way we work is we just send the message, and the only timeout we have is basically kicking the member out of the system, right? So we assume that if the member is still part of the distributed system, the message will get there eventually and we'll get a reply back. And like Alberto was saying, like there's no, I don't think there is a sequence number or something associated with those messages. There's no way to say, okay, I've already applied this message right now. It's just, I think we are kind of relying on the TCP connection to make sure to send it. As opposed to like our client servers, our client server messaging, you know, it sends a message with the sequence ID, and then it can time out and then retry and then check to see, okay, have I already applied this message, and it does all that, but not at the peer-to-peer level.
Yeah, one thing that was striking to me is that this reply processor 21 class was doing some wait, and there was no timeout for that. I tried to set a timeout of several seconds and repeat the test, but it didn't help. I mean, it helped in some cases, but in some other cases, it kept waiting forever. So again, I don't know very much that code, but even the timeout was not enough. So I guess we need much more investigation. But I agree with Bill. I mean, in theory, it sounds like using a timeout would be almost what we need.
The thing is, like, there's sort of one-way messages, right? So there's stuff that we send that it's important that it gets to the other side and has whatever effect it's supposed to have. But we're not necessarily waiting for a reply in a reply processor, right? You know, I'm trying to think of a good example. Well, like your ACK example, right? Like it's an, yeah.
I mean, maybe, I mean, the only thing, the only indication that we have that something has happened is the fact that connection is closed. Can we use this information to invalidate some things, and maybe to, you know, to go into some recovery mode and check which threads were waiting, and try to clean something in this manner, because the only piece of information that we have is that connection has been closed. So it should be rare, but if that has happened, maybe some recovery logic makes sense.
Yeah, I think the problem is that I don't know if we could spell out what that recovery logic is in every case. I mean, one option would be you just kick both members out of the distributed system, right? Like you'd have to, like that would be valid. You could say, okay, both these members are just dead now, Beyond that, it's kind of on a message by message basis how you would recover from that. I think, some messages maybe you still have the context and you could retransmit it, but I think it'd be hard to do in sort of a general way.
I think you make an interesting point there, because in a way, one might look at it and say this problem gets caused because members get kicked out based on UDP, and we don't know that they were disconnected because only the TCP connection has been cut. So maybe that's really the solution, is making sure if you lose the TCP connection, you get kicked out.
Now, the problem is I think we'd have to kick out both sides of the connection, right? I think. And that then in a lot of scenarios you lose redundancy or something.
But if we lost the TCP connection, why are we even bothering with this thread anymore? Why don't we release it and go into failure and return the failure, propagate the error up the stack?
I think it really depends on the message, right? So we can think about messages that are just doing cache operations, like a put or something. So I could totally see, like, I'm on the primary, I was trying to put to my secondaries, I lost my connection. Maybe I can replicate I could propagate the failure back up the stack. It would mean my primary and secondaries are inconsistent potentially, but I guess I could get my thread back and propagate it up. There's other messages though that are like more, like they're lower level fundamental things. Like maybe I'm getting a lock or releasing a lock or something. Like releasing a distributed lock. And if I just, throw an exception and let that not happen. Like I think there's things that could just kind of basically leave the system in a weird state, right?
That's also why you can't just time out too. When you time out, what do you do when you time out? Do you retry? You can't retry because you don't necessarily have a message to retry. If you just throw an exception at that point, the state of the system is inconsistent. It's either the replicas aren't consistent, or like Dan said, you lost a lock, or you've not released a lock that you thought you released. Yeah. The only reason that thread should stop waiting is if the member that it's waiting for goes away. That's why. So it seems like the best solution in this case is to kick that guy out. But if the failure happens between the two proxies, you don't know who to kick out. You have to kick them both out. So like the proxy and the server have to be the same, or the member. And if either one of those crashes, that's the end of that server, right? So that seems like you could handle that. Like I said, between the two proxies doesn't seem like it's as easy to handle. Yeah, I assume these proxies are just pass-throughs. They don't have any retry logic either. Is that true? Because then if they're retrying, then they could handle it. But I mean, there's some retry has to happen and it has to be held and known. So, yeah, just seems like definitely a tough issue for sure. I mean, in this case, this case you've shown, you can just kill that thread. You could just interrupt it and you'd be fine, right? Because it's already retried. You know, the client already timed out, retried, and it succeeded. So that thread that's waiting is fine to just kill, but it's not always the case. That's my 2 cents anyway.
Yeah, so I do think like probably the only way to really fix it is a little bit lower level, right at the messaging level itself, like at the connection level itself, where we create a more reliable connection that could handle TCP failures and reconnects. I was also wondering, like, is there something like I don't know enough about Istio and how you have stuff set up in Kubernetes. Like, if there was a way to basically restart the member and the proxy at the same time, right? Like every time you take down the proxy, you take down the member first or something. You know, that might be another way to just not have this problem happen. I'm not sure if that's really possible or not.
We were thinking about something like that. We understood a while back that that kind of behavior could potentially solve this issue, but unfortunately, Kubernetes doesn't provide, at least at this point, it doesn't provide a way to couple two containers in the same pod. So if one restarts, that the other does also. And there is no such feature currently, unfortunately.
And Envoy doesn't support UDP, does it?
Nope. There is some talk about Envoy also intercepting UDP, but I think that they haven't made any real progress on that. But again, if it did intercept also UDP, the restart and the startup is quite fast, a couple of seconds, so not enough time for the member to be evicted.
Wonder if you have exhausted the solution space in this meeting. So maybe the next step is to take this back to the mailing list and see if there's a solution that you folks would like to go with and propose that as the next step. Does that sound acceptable to you, Peter?
Yeah, that's what I was also thinking. Alberto, do you have maybe something to add?
No, I mean, one of the questions we had for this meeting was that if it was reasonable that we ask this to Geode, or if Geode says, okay, you cannot have proxies between servers. Once I think we have agreed that this is a possibility, then we can think about trying to fix this. It sounds like a hard problem. It seems that maybe we have some very, I don't know how to call them, not very fine solutions in which we can, we kick servers out of the system and at least we get out of the problem, but that's not the best solution. I think we should go back to our offices and think about possibilities. And of course, any idea that you guys have, because you guys know much more than us, it would be very welcome. Any crazy idea that we could take and, I don't know, polish it, maybe it would help us, as it has happened in the past. So it would be very welcome.
Yeah, definitely. I think solving this problem would generally be great for everyone in the community. All right. I guess that wraps up this part. I don't think there was anything else on the agenda today. So in that case, thank you so much, Petar, for presenting, and thanks everyone else for participating. And trying to brainstorm some ideas.
Sorry, Alexander. I think I have a quick question which is not in the agenda, but is there any Geo native guys in the call? Or maybe not?
So I think if there are any Kubernetes guys.
No, Geo native guys. Any contributor from the Geo native project?
Native.
See, I don't think I see any of them in here right
Okay.
now.
So then never mind.
Okay.
Never mind. I'll reach them through the mailing list. Thanks, Alexander.
Of course. All right, then. Have an awesome rest of your day, everyone, and see you all next month.
Thank you, everyone.
Thanks, guys.
Thanks.
Bye.
Yeah, thanks for bringing this up.
Thanks.